Welcome to this presentation on static electricity. Whether it's the loading area of a propane bulk plant, a loading dock for propane bottles, or any transfer area, we hope to give you some insight in how to minimize any potential risks from static electricity discharge.
My name is Chad Ackner. I'm the Technical Service Advisor for Dealers LP Equipment and the R.E. Michael Company. R.E. Michael has corporate headquarters in Glen Burnie, Maryland, while Dealers LP Equipment has locations in Davenport, Iowa, Louisville, Kentucky, Hickory, North Carolina, Jackson, Mississippi, Dothan, Alabama, and also Memphis, Tennessee. It's important to note that anything discussed today should not in any way be construed to override any of your local applicable codes, any of your insurance requirements, or any of your company policies. Anything referenced today is from NFPA 54 and also NFPA 58.
Part of the reason that you're here today is because of Section 4.4 in NFPA 58 regarding the qualification of personnel. And it basically says that persons who transfer LP gas or are employed to transport LP gas, or whose duties fall within that scope of the code, shall be trained in the proper handling procedures. It also states that refresher training is required at least every 3 years. Additionally, all training must be documented, and that documentation must be retained.
All propane installations must comply with both NFPA 54 and NFPA 58. Those installations must also comply with your local AHJ, or authority having jurisdiction, which may be a local code enforcement agency or a fire marshal. Company policies must always be followed, in addition to following manufacturer's instructions. Part of the code is to actually follow the manufacturer instructions, whether it pertains to NFPA 54 or NFPA 58. So that is actually written into the code. Always work safely, document everything that's performed during the installation or during the service work, and retain all documentation. A breakdown of the differences between NFPA 54 and NFPA 58 are that NFPA 58 will cover everything from the container all the way up until the outlet of the delivery regulator. Now that may be an integral twin stage regulator or a second stage regulator. NFPA 54 covers everything from the outlet of that very same regulator all the way inside the building.
Some of the things we're going to discuss today are determining exactly what static electricity is and how it occurs, whether or not it can ignite propane. Also, how do temperature and relative humidity affect the level of static electricity? Can static electricity be fully eliminated? How do you reduce the exposure or your exposure to static discharge in your filling operations? And we're also going to discuss some prevention through training and also auditing. In this training seminar today, we're going to specifically talk about protecting employees and customers, being proactive in incident prevention, allowing employees to become your safety partners in the operation, protecting assets, and also finding ways to lower insurance and operating costs. Static electricity is an electric charge that can be collected and actually held in one place. The meaning of static is not moving or changing. Static electricity is also different from current electricity. Current electricity is the continuous flow of a charge in a complete circuit. In static electricity, electrons will actually build up in one place. A current, which is that spark that you actually feel or see, is a pathway through which those electrons will travel. And speaking of that pathway, the smallest static spark an average person can feel is about 3,000 volts. So will propane actually ignite from static electricity? At about 3,000 volts, a static spark can deliver about 0.50 millijoules of energy. Propane with air mixed between 2.15% and 9.6, as we all know, is that flammability range of propane, can ignite with about 0.25 to 0.30 millijoules of energy. So that is well below what a 3,000 volt static spark can deliver. Unfortunately, in the propane industry, static electricity can cause some real problems. In the next few slides, we're going to detail some incidents that have occurred over the past few years. Here in Willoughby, Ohio, 20-pound cylinders were overfilled by a third-party contractor and then delivered to a distribution facility. Soon, the pressure relief valves began to open, relieving propane out of the overfilled cylinders. These cylinders were stacked onto a pallet and secured with stretch wrap. The stretch wrap was used to hold the cylinders in place. When the plant employees noticed that the relief valves were opening on the pallets, they began to unwrap the shrink wrap or the stretch wrap from the pallets. And once they did that, the static that was generated from unwrapping that plastic actually ignited the propane vapors. Unfortunately, when everything was said and done, the plant was a total loss. Here we have a situation where cylinders from an exchange program were stretch wrapped onto a pallet. And employees at the yard where the pallets were delivered actually saw a small yellow flame inside the wrapped pallet of cylinders. They quickly extinguished the flame, but apparently soon the fire regenerated and was burning the entire package of cylinders. Everybody was evacuated. No injuries were reported, fortunately. The fire was actually believed to have started from a tail of the stretch wrap around the outside of the pallet blowing in the wind, creating static. The source of the gas, of course, was from one of the empty cylinders being returned to the plant for recertification. In Yuba City, California, a plant manager reported a possible fire in one of their filling areas. Employees that were in and around the fill area actually heard a pop or a popping sound, and some of them said they saw flashes. They did do a full investigation after that incident, and nothing was found. However, there was a surveillance camera caught, and if you look at the image on the screen, you'll see a very faint, small blue arc in the middle of that white circle. And the spark or the arc was actually given off by the employee's clothing. If static means standing still and electricity is excess or deficient electrons, static discharge is the equalization of the charge. Here's an example of static from lightning. So how is static electricity generated? Well, it's generated by friction or something called tribogeneration. It's basically when two materials touch, they come apart, and one material will actually pull the electrons from the other. That will create a charge. We've all experienced walking across a carpet and then touching the light switch. That's actually one of the most common examples of a static discharge. Another way to generate static electricity is to transfer fuel at a high velocity through a small opening. A perfect example in the propane industry would be the transfer of methanol. We've all experienced the static cling of plastic wrap, or even removing a sweater or a jacket in the winter months when the humidity levels are low, and hearing a snap or a pop as we're removing that jacket or that sweater. But what about the hazards in the bulk plant? What materials are present in a bulk plant or a loading dock that would create a hazard in our industry? Well, one thing would be to remove the stretch wrap from cylinders that have been transported to your facility. or removing cylinder wraps and sleeves that sometimes come from either requalifiers or straight from the manufacturer. Changing any clothing in a controlled environment is important, as well as the types of materials that the clothing is made from. Some of the types of clothing material to avoid might be polyester, nylon, or any microfiber. Some of the cotton or cotton blends will generate less static electricity than any synthetic clothing. This is a great example of what you might see at a typical loading dock or at a typical transfer facility. In this example, we see multiple motor fuel cylinders stacked on top of each other with a standard 40-pound cylinder in the center of the floor. An employee appears to be wearing a polyester blend jacket on the left. You'll also notice that there is a plastic garbage can full of stretch wrap that presumably came off of a pallet or multiple pallets of cylinders. There's also plastic cylinder mesh under the 33-pound cylinders. If you look up to the right, you'll also notice there's a customer in the transfer area. All of these are red flags and should be corrected. It's a simple thing to do. Bonding and grounding can help reduce static that builds up from fluid transfer at a bulk plant or any transfer area. This is a simple diagram of how the bulk storage container is grounded, and also the container that you're delivering into from the bulk storage is bonded to the bulk storage tank as well. Here's the difference between conductors and non-conductors. A conductor is a material that will allow the flow of electrons. Some examples might be metals, the human body, wet fabrics, and even wet concrete. A conductor, when charged properly, will create an arc capable of igniting propane. Non-conductors are any material that will resist the flow of electrons. Some examples might be plastics, vinyl, dry fabrics, and dry concrete. What about some of the hazards and some of the typical energy sources at a propane bulk plant? Were you aware that stretch wrap with a moderate wind will generate over 10,000 volts? This can create a severe hazard. HDPs, or high-density plastics, are also extremely good generators of static electricity. Some risk areas to look for at a propane bulk plant might be dome covers, stacks of 20-pound cylinder trays, or even underground tank collars that are in storage awaiting use. Be aware of these materials at your bulk plant as well, along with what their corresponding potential voltage ratings would be in certain conditions. Cylinder packaging materials, sunshades which are susceptible to the wind, PVC pipe, and also plastic drums. All of these materials are very common and must be identified. But the most common conductor in any operation is the people, or human beings. They are excellent conductors. As I mentioned earlier, the smallest static spark a person can feel, see, or hear is measured at about 3,000 volts. Individuals coming in contact with a non-conductive material, for example, plastic film, have been known to throw an arc of 3/4 to 1 inches long. One of the easiest and most responsible things to do would be to limit the access to any discharge area. For example, customers or contractors that are not performing a specific duty in that area. Allowing a customer or a patron in the transfer area or the static discharge area happens all too often in our industry. This should be a practice that's reviewed and ultimately addressed. Relative humidity plays a huge role in not only how much static electricity is generated, but how long it will last. By looking at this chart, you'll notice that the lower the relative humidity, the higher the static electricity charge can be. For example, walking on a carpet will go from 1500 volts with relative humidity above 50% to 30,000 volts with relative humidity below 25%. Walking on concrete, again, goes from 500 volts to 8,000 volts. Rubbing a plastic bag goes from 1,200 volts above 50% relative humidity to 20,000 volts below 25% humidity. And brushing your hair goes from 0 volts when it's wet to creating 25,000 volts when it's dry. Another important fact to remember is that static electricity is never eliminated. Again, high relative humidity reduces the level of static generated, but it does not eliminate it. Different parts of the country traditionally have higher levels of relative humidity than others. Those areas generating higher levels of humidity will have less instances of any static electricity discharge. However, regardless of where you reside, the risk of static electricity never goes away. One thing to consider is to install a humidity gauge on the loading dock or in the bulk plant transfer area of your operation. What are some of the other things we can do to decrease the risk of static discharge at our bulk plant or transfer areas? These areas may include bulkheads and transfer connections, cylinder filling areas, motor fuel filling areas, or areas where cylinders are evacuated and disposed of. The first thing, and maybe the most obvious, is to install a static control area sign. What this will do is it will restrict employees or patrons within 25 feet of the transfer area or the static discharge area. Another good practice is to ground and bond any filling equipment that possibly could convey in transfer areas. Here are some additional countermeasures. Maintain an increased level of awareness when relative humidity drops below 50% by installing a gauge. Requiring employees to wear ESD-rated footwear in static discharge areas is also important in addition to grounding and bonding. Other things to consider with regard to countermeasures are requiring anyone that's allowed inside the static discharge control area to wear either cotton or cotton blend clothing. Try to steer away from nylon, wool, or any microfiber type of fabric in that area. Also, try to avoid removing any jackets or sweaters within that designated static control area. Try to move a minimum of 25 feet away from that particular area. Also, any plastics or wrap material should not be allowed in the zone. After handling any plastics or wrap material, make sure to discharge yourself before entering the static free zone. Make sure you ground yourself first before making any liquid transfer. A charge can actually be created by simply exiting a vehicle. Also, be aware of your surroundings. Make sure there's no customers or patrons in the area. Make sure anyone that's within that zone is allowed and required to be in that zone. Static electricity, again, is all around us. It is not possible to eliminate it completely, but through proper training, whether it be through reading or taking seminars like this, is very important. It's all about creating awareness. Training and auditing to make sure that you're in compliance is also very important. PERC has a field evaluation guide available. It's important to not only check out that field evaluation, but ask your employees to take that quiz that's provided in the PERC booklet. The name of the booklet is Static Electricity in the Propane Industry, and there's a lot of great information in there. Here's some quick static discharge prevention tips. Know the area, know your surroundings. Ground your personnel, make sure everyone is properly grounding themselves. Make sure you have the proper clothing. Clean up your facility and clean up your work area to make sure that it's easy to navigate and there's a low chance for accidents. Follow the code, always referring to NFPA 58. Make sure you observe what you're doing. Most static electricity comes from friction between materials. Always remember that. Limit the access to your restricted areas. And also listen to concerns or complaints from other personnel, whether it be fellow employees or otherwise. When reviewing any PERC static electricity discharge document, always refer to the glossary for a better understanding and explanation of the terms used. Now it's time for some Q&A. Number 1, true or false? Static electricity equals electricity in motion. The answer is false. Number 2, the smallest static spark can generate blank volts. The answer is 3,000. Number 3, true or false? Relative humidity has little to do with static discharge. The answer is false. Number 4, blank causes static electricity through movement or separation of materials. The answer is friction. And number 5, true or false? Customers should be kept out of static discharge areas. The answer is true. Thank you for watching this presentation on static electricity. Hopefully you've picked up some pointers and you can bring some information back to your peers to share with them on making our loading areas and our transfer areas safer. Thanks very much and have a safe day.